So hi everyone, welcome to what will be probably be around about an hour, maybe a little bit longer session on intelligent query processing for the SQL Server 2022 release. So kind of a little bit at the end towards of last year, we had our SQL Server 2022 come out, and of course there was a brand new set of features in there. And some of the most exciting features I found, and I've actually done some sessions already around this and a workshop, which I'll explain in a moment, around the 2022 release and things, capabilities that we have in there. And tonight we're going to focus in on one specific area, kind of known as the intelligent query processing, and specifically Query Store, kind of the engine, the capability to store and understand the executions of our code. So we're going to be taking you through some demos, some explanations, some slides and some material, and also show you where you can actually sign up for the free course materials that I did for the SQL Server 2022 workshop. This is the same workshop from the likes of Bob Ward, Buck Woody, Anna Hoffman, those folks who recently have also delivered this SQL Bits and in the US as well. So they created the content. I've done a one-day delivery of this, and I'll show you that shortly, but this is a part of that. So there's more stuff that kind of flows before and after this, but today we're going to focus in on just doing the intelligent query processing. So here's the SQL 22 workshop slide. What I've done is I've butchered the slides a little bit to just focus in on what we're going to concentrate on, but the full deck and all the code and all the slides are available in the material I'm going to make accessible to you. So module 3, which is where we're going to kind of kick into straight away, we're going to jump straight into here, is around accelerating the performance of the engine and your queries specifically by pretty much doing nothing kind of in terms of tuning, but kind of like in the engine doing that heavy lifting. So we're going to show you what's the built-in new in performance capabilities, the AI, the built-in kind of new understanding of what's happening in your engine, in your queries, and making better decisions on how to store plans and executions and metadata around that. So we're going to explore what that's there today. If you have questions, we do have the chat window. We're also going to be kind of taking a few pause along the way just to check on those. Of course, right at the end, I have the ability to also answer those questions. So I'm hopefully going to be kind of forward facing, looking at the different cameras a little bit, little screens I have. So if I'm flicking around a bit, I do apologize. I've got things are weirdly set up at the moment, but because for some reason all my screens have kind of reverted to one side only. I haven't figured out what that solution is yet. So here we're going to jump into SQL Server 2022, and all I'm going to do is highlight the specifics around the intelligent query processing, the IQP. So SQL Server has been around for a long time. I know I've been using it for 20 plus years. Version 7, actually 6.5 to be honest, was the first version I had. 7 was the one mainstream one I started with. So even back in the late 1990s, would you believe, I was using SQL Server, and I've pretty much been through every edition and the kind of version of that since. And the main thing we're going to focus in on is from 2016. The kind of actual supportable versions of SQL right now is 2016 and above. And Query Store, although it kind of was a little bit in 2014 behind the scenes, Query Store really came into existence in 2016 version of SQL Server. But every edition since then, so 2017, 2019, and clearly obviously 2022, we've had an improvement on the capabilities of the Query Store. So Query Store, kind of say, first appeared in 2016. In 2017, we got some additional kind of enhancements to that, and we called it the adaptive query processing, and there was some automatic tuning that happened under the covers based on some of that adaptive query capabilities. This is taking the query plans and things like the execution stats, so we're using the DMVs and that information, and we're kind of figuring out how to run our queries better. Oops, looks like something's fallen over. Oh, join, that's just my dog knocking stuff over. 2019, we then kind of brought into the world the intelligent query processing kind of, so the IQP was really kind of brought in right there. 1 second, just checking on my dog. You all right there, puppy? Okay. So Something fell over and I think you got a bit scared. So intelligent query processing kind of first made its appearance in the 2019 release. But we've taken that and we've moved it on in terms of additional things it can do. And we're going to go in a deep dive a little bit on those this afternoon or this evening or morning, whatever time frame it is for you. So let's look at what we have here and kind of click a couple of these slides forwards. So the one in blue, the one right at the end there, is what we're focusing in on. And this is the built-in query intelligence. So getting the best performance out of the engine based on your query and the execution and things like query stats and kind of indexes and the different kind of engine improvements, that fixes that we've done to the engine over those times to get the best performance for OLTP and also for those data warehouse scenarios as well. So kind of those big non-clustered data warehouse performance up to 100 terabytes of kind of size structures. But we're going to be really kind of focusing on specifically some capabilities of this engine. So the thing that we're going to be looking at is this second kind of cog in our SQL 2022 world, the built-in query intelligence. I'm going to break this down into some of the different things that we can do and the improvements, and I focus specifically on where the query store comes into play here. Okay, just checking we don't have any questions at the moment before I get any further. So I'm just going to have a quick look at the question screen. Yep, no, if you have any questions, do get those into the chat window, folks. Excellent, cool. Right, I'll keep that on my screen there. So I've highlighted in red here a couple of items that are specifically what we're going to be focusing on tonight. So clearly, we have different versions of SQL Server, from the free Express version through to the standard or enterprise. And remember, this also kind of is kind of relayed again into the Azure SQL product as well. So the things that we do kind of really in the enterprise will be really the same things we get in a lot of the Azure SQL. But if we're talking about the SQL Server 2022 kind of box product, we have Express, Standard, and Enterprise SKUs here. Now, we got the built-in parameter sniffing optimization, or sensitive plans as kind of is probably the new term for it. I always think of parameter sniffing, basically having the wrong type of plan there. So a scan when we really need to seek, and a seek when we really need a scan type of operation. So we kind of have these sniffing problems. Well, the kind of parameter sensitive plans, parameterizing those plans so that we have more than one type of plan now. For example, we might have one we pass in, and initially it gets an index seek. And then when we run a different parameter, we get a lot more data, and we're looking really to be then a index scan. But really then, if we run it again, we might then have a scan occurring when we really need to seek. So we're kind of doing a lot more work. We're using a lot more CPU, a lot more processing. So we've got these plans that don't really fit for different kind of maybe different parameters that kind of are uneven in the volume of rows that we get in them. So we have these parameter sensitive plan optimizations where essentially under the covers, there's actually a kind of a variant occurring now for that plan based on the ID value, and potentially we can have more than one plan type for that parameter for that plan based on these different variances. And there's some materials out there that kind of explain this a little bit as well. I'll show you maybe where you can find more information later on that. New databases automatically get Query Store turned on. For older databases, you had to go and kind of turn it on, and you had to run some code. I'm going to show you what the code looks like. Basically, we used to turn it on, but now by default, a new database, Query Store kind of automatically turned on. Really good. Standard, we get that kind of those features kind of brought in from the Express version into Standard, and of course also into Enterprise. But Enterprise also has additional capabilities. They're going to be called DOP, degree of parallelism. So I did, I think, a full-hour session recently in a video, and I'll show you where that video is. You can watch it around degree of parallelism. We will do some demos tonight around that, but it won't be like a full hour. We've got the cardinality estimate feedback. So we basically get information now coming back from the plans and executions to understand whether we've got a good cardinality estimation. Do we work out how many rows we think they're going to be coming back based on statistics and the indexes we had that actually were true? And then over time, are we getting the right information? So we've got this feedback mechanism that will help us maybe reevaluate when that needs to be kind of figured out. And central to kind of everything we do inside of SQL is memory. It's a kind of in-memory service. We basically bring data into the in-memory data buffers. We process everything in memory, and then we kind of maybe harden those results back to disk. The memory grant feedback is essentially saying how much data or memory we need for the data we're processing, so we don't have things like spills that can be really expensive into temp DB. So we get this feedback mechanism again on the use of the memory grants. We have more efficient use of our memory grants, and the concurrency and other performance can improve because of that. So we've got these 3 additional capabilities, feedbacks essentially, in the enterprise for degree of parallelism, for the cardinality estimation, and also for the memory grants as well. Okay, and I'll show you where we can do some exercises, some demos to look at those in a little bit later in this session. Okay. So that's kind of before we get into those demos and show you stuff. Let me kind of get my my screen up. And I know kind of before I started, jump straight in, I didn't give an explanation of who I am. So I'll put that at the end of today's session because I was really keen to kind of get started in. But I'm a Microsoft certified trainer, I'm a data MVP, I'm running and operating a consultancy and training business around the data platform. So SQL Server is my bread and butter for many, many years. So this is why I kind of have a love of this. I've actually done about, I forget how many now, but it's kind of 400 or 500 sessions at different conferences over the years. And I'm still doing sessions like today on pretty much a monthly basis out there. I have some other Power BI or Power Champ kind of stuff tomorrow, which is kind of the Power Platform stuff. So I'm also doing stuff around that these days as well. But here we're looking at query built-in query performance intelligence. So basically no changes to your code, no refactoring, no changing, just upgrade to the latest compat level 160 in your 2022 release, and you get these new capabilities. So we have a few different kind of compat levels, depends on what you have set, depends on what you're going to be able to access. Okay. So here we're going to go in and explain now the details of that, the new query store, as they call it, kind of the more enhanced version of the query store, etc. And we're going to also do some demos. So I've got a SQL Server 2022 Dev Edition in a VM already spun up. I've done some restores of some databases. I've prepped up some data ahead of time, and we'll be doing some live demos as well with the query store, with the extended event sessions, etc. Okay, let's look at what we have today. By the way, the stuff I'm going to show you is part of the SQL Server 2022 workshop. So actually, what I do, why I've said that, let me kind of quickly show you this so I can kind of bring it up. So where is that workshop? Here we go. I found it. Cool. All right. So this here is the Microsoft SQL 2022 workshop. It's from the Microsoft team. Say I've done a delivery of this at the end of last year, and you can join this free workshop class. I'll give you the links to sign up for that. So it's completely free. It has videos of the previous session. They've been trimmed a little bit from some of the content. So if you weren't there, you would have kind of missed a little bit of the date, a bit of the content. But it has all the modules, and we are currently going to be looking at module 3 today. So as we go through and look at the content, you'll be able to see, oh, sorry, click the wrong thing now, one moment. You'll be able to see, let me click it again. Here we go. You're able to see each of the slides and the lessons and the content, as well as kind of the stuff. So what we're doing today will also be as part of this delivery. You can go and access that. I'll show you those links a little bit later. Okay, let's go back to and jump into the query store and why actually we need it in the first place and why they're making all these improvements over time. Okay, so the query store is to capture information that is the query plan, the SQL plan, along with related information. So there's about 8 or 9 internal, I can't remember exactly how many kind of tables for each user database. You don't really apply query store on the system databases. I think you can on something like master, maybe MSDB, but why you'd want to know. But for user databases, we're going to enable the query store. It's going to capture some key information. It's going to capture the query plan or the plans that exist. It's going to capture execution information. So the DMVs around execution, procedure cache, the DMVs for execution stats, that kind of stuff. We're going to capture that information along with the wait stats. Wait stats, if you're not familiar with those, are basically understanding how the execution of the engine is processing your queries when it stops and starts because of resources it's waiting for. And those DMVs that we can kind of query, the dynamic management views, can give us information. And the wait stats is the key one to say, when do we have maybe a lock or some kind of problem with the performance throughput of our query. We capture all of these stats, the DMVs, the wait stats, the execution stats, and the query plans, and we then reprocess that. And we basically have the ability to see this information and query these internal query store records, but make use of them as well to proactively look at what's happened to the queries and maybe suggest changes to maybe things like degree of parallelism. So actually taking it from a larger number of CPUs that are being used in parallel to a smaller number, but still having the same execution time, but basically kind of then making sure concurrency and performance are even maybe improved or kind of at the same level they were before, using less resources. So the query store is going to be turned on by default now for new databases. It also, I think it still was in preview, but if you're using availability groups for kind of offloading your readable kind of queries, etc., your read replicas, essentially you could even have query store against those readable queries and actually using that, supporting that information as well. So that was something that also got introduced in this latest release. It helps us with the plan hints. So you ever heard of kind of a query plan hint, basically to kind of say how that query plan should be kind of executed, what type of kind of merge joins or index seeks or index kind of range queries, that kind of stuff are happening. We basically are kind of improving that, but again, with no code changes happening under the covers. And there are some additional kind of scenarios now that have been improved. So kind of straight out the gate, your queries upgrade to the latest compat level. So we're talking about the compat of 160, that is, in the 2022 release, to get some of these new features. I'll show you where kind of this thing is kind of turned on. So you have our new optimizations. For the query store, we're looking at really just 2 of those. So we're going to focus in on degree of parallelism feedback and cardinality estimation feedback, because these are both used in the query store, in the feedback store, and the hints underneath the covers here. Okay. And there is also a link there Benji's put in for that degree of parallelism feedback. So that query, video for the degree of parallelism one I did that goes into a bit more detail than I'm going to do tonight. You can look at that as well. And it will also be on my YouTube channels as well. Okay. So here we can see that we have the query store now providing this information, this feedback to the engine that helps it understand, okay, can I do things better? Can I do things with less resources? So let's look at what we're going to do with the latest release. Now, kind of we have upgraded directly into 2022. We have optimized plan forcing. So it's kind of reducing the recompilations, the expensive operations to recompile your plans and to persist some of those compile steps for our force plans, so we don't kind of are using CPU for compilations where we don't really need to be. So we improved that. We've also, with the 140 or higher compat, you then get the memory grant feedback persistence. So when you, we're going to store that information in some internal tables, but basically what happens is when we kind of turn the the service off and back on again, we were losing that grant feedback information. Well, now we're doing some persistence of that. So that's going to help with cache evinctions and understanding kind of which plans we should be using, which ones are efficient. But the main stuff comes in with the 160 compat. So we need to upgrade our database, our user database, to 160. And then we get that PSP for parameter sensitive plans. We're not going to talk about that today. I'm going to kind of move across from that because it's not using the query store. And to be honest, we could spend an hour just on that alone. And there are some good stuff out there already for that. Cardinality estimation feedback. This is where we are using that feedback mechanism, understanding the query execution and what kind of estimates we worked on, how many rows were coming back for each of the internal structures, and then using that to figure out, did we get it right actually? How close were we? Is there some kind of actual stats that will help us kind of give us the understanding of that information better, so we can kind of do things in a more efficient design from a plan perspective going forward. And degree of parallelism feedback is another one we're going to look at, which is getting that parallel. Basically, what we're looking for is the minimum DOP the query really can use to get the performance level that we need. And that's hard to do because you've got the server instance level DOP, you've got the user instance, the kind of the database level DOP. You've pretty much got a DOP you can put on a per query basis. Figuring that all out dynamically and working out what's the best is going to be hard. So we want to kind of figure out for that specific query, what is the best DOP without doing a recompilation, which is out kind of that expensive recompilation. We could do that. We don't want to, it's too expensive. We want to get that better DOP max dot value, the lowest we can go with, without compromising performance. And we'll show you examples of that in our demos coming up. So these are all using Query Store. Optimized plan forcing, memory grant feedback persistence, cardinality estimation feedback, and the DOP feedback as well. Okay. There's been some optimizer fixes. There's been some additional things that we've done inside the engine. So not just getting just those, but you get a whole bunch of stuff. But the one I probably didn't kind of memory kind of is, kind of probably the adaptive joins as well. And that kind of stuff will help with performance. So we're looking at kind of getting the best out of the service without having to do lots of code re-engineering again. And that might change over time. This is one of the things that I think people sometimes fear. We're not trying to do query tuning. We're trying to do workload tuning. Okay, so we're trying to get better workload throughput. I could query tune all day long, and I've spent years literally kind of learning the dark art of query tuning and understanding the engine and the structures. And I went through kind of the MCM program and did all that kind of stuff. Loved it. Really nerdy, techie stuff, awesome. But ultimately, next week, a whole bunch of new data could come in, could kind of mess it all up again. So we want to be adaptive, intelligent in terms of how the engine figures this stuff out, and constantly maybe making small tweaks. Your engine in your car makes thousands of calculations. The kind of memory, kind of the module for computers in there are constantly adjusting values all the time. That's essentially what we want the engine to do. We want to make very minor adjustments to get the best performance at all times. Okay, so these are the improvements that we have. Let's look at what's there. Query Store's on, read replicas from AGs, plan hints or hints to shape the plans, and the Query Store being the place where all of this data kind of is made available. And we've got queries we can run then to look at that data. So I've actually removed a whole bunch of slides kind of between the, so if it kind of jumps a little bit, it's because I've kind of taken some slides out of the flow that will be in the complete training you'll be able to access. So for read replicas, we have essentially two query stores. We have one in the primary database, and what was going to happen, those query store queries are then going to kind of come either from the read replica or the primary replica, depends on which database you actually kind of end up kind of hitting. So we want to be able to do analysis because we might have different plans based on information in those and the workloads that we're running against those services. So what do we have around here? So I'm going to kind of show that we had this kind of example. I should have probably taken these slides out. So if you're not familiar with a memory grant, look at the slide. This is the query. Look at this slide now, and you can see that essentially this specific one has a sort because we've got the order by. So without the order by, we actually aren't, we're just getting the data back in whatever order SQL defines it's going to be. Generally, that will be the sequence of the physical order of an index that it reads in the way. But sometimes those reads are not done in a continuous fashion. They might be kind of doing hooking onto the back of other queries and stuff like that. So we get the data sorted with the order by. That's an expensive operation. This is where the memory grant basically is going to be kind of improving by understanding what we're spending here our time on. Okay, so we need to work out what the memory grant was before, what the memory grant was during the execution, and potentially we might see that, you know, for example, it depends on the number of rows. So remember, it's all about how much we think we need to be able to do this execution efficiently. If I think there's only going to be 10 rows coming back, there's actually 12 rows, no foul. It's all good. You know, if I think there's 10 rows coming back and we get back 20,000, I'm probably going to need a bit more memory than was probably allocated to me at query time, the time that I executed my query. You spend that up and say, look, instead of like a million records, I'm looking at 100 million records. Well, I'm starting to do some problems in that the memory grant won't be enough. I get to the point where I've used all of those memory pages. I'm going to then start spilling to disk. And literally, it won't spill just the pages it needs additional, it will spill everything. So this then suddenly hits your performance really bad. So memory grant is really important to get right. Now, we can help with some of that with some governance, so kind of some controls inside the engine, kind of sizing up queries, etc. But we need this feedback mechanism to make sure that when we kind of find these problems where we're getting the memory grant incorrectly assessed, and we're maybe doing too small a memory grant and causing the spill, but also conversely, a large memory grant means that we're kind of throwing too many resources at it when we don't need to. Okay, so that's a problem as well. So let's look at what we can do here. Remember, this is per query. So think about if you've got like lots of these queries happening. This is why memory is a commodity inside SQL Server that has to be very well conserved and utilized. We use it, we kind of make use of it, we throw it back into the pool, and then the next query gets it, kind of thing. But if we kind of constantly over edging, over kind of allocating, that's going to be maybe some queries are kind of being held back from running and waiting because we don't have enough memory grants available, space available for us, and that's a percentage of the total memory that currently is available for that instance, etc. So these are the things that we can do. There's an internal kind of thing that we call a resource semaphore, basically a signal that we tell kind of the engine how we're doing. So if you got like it running high, that's meaning kind of you're running low on memory, these kind of things. So let's look at a 1 meg memory grant. We actually need 500. Uh-oh, spilling that onto my temp DB. don't want to do that. Cause a whole bunch of problems. Definitely a no. Spilling is a problem. We're actually going to track for spill events inside of our extended events, and also see when we evaluate the query plan what memory grant we got with that, and then actually you can tie that back a little bit to what did we actually utilize and did we go over, and are then the amount of memory grants that we're kind of supplying for that query too high or too low. Some can be very variant in their needs. Also think about things like IO completion, where you're kind of going to have it waiting for the IO to complete. That query hasn't finished running. IO, I'm waiting for you. My dog's called IO, by the way. Can imagine why. It's actually no, he's named after a Jupiter moon. But people said IO. I was like, and some of my techie friends went, "You've named him after input output." I went, "Nope, after a Jupiter moon." But yeah, kind of, we're waiting on the data to come in. Now, what that means is the memory grant itself is still being held until that query completely finishes, and only at that point we then release it back to the pool. Okay, so there's things like that. So the memory grant feedback essentially works by looking at the memory resources, looking at the temp db spills, looking at the large resources, resource semaphore weights that we're kind of waiting on this kind of governance control to say how much memory and allocation these services get. Now in SQL Server 2017 and 2019, we improved that. We started using batch mode a little bit. We got a kind of an observation of how much grant was actually being used. And then we might kind of adjust the next execution if that was kind of maybe too low. So these things started to improve. And that was the intelligent query processing engine improvements that came in with that. Okay. But what we're going to show you is an example here where if the memory grant is constantly kind of going up and down and kind of it's volatile in its nature, how much we need. Sometimes we're going too high, sometimes we're going too low. We want to try and figure out what that is again. So we look at basically kind of doing more of a persistence of that inside our query store to survive with the plan cache and say, look, okay, look, based on the executions, this is what we needed, this is what we last used, and kind of it can be a bit more follow the workload plan. Remember, we're trying to tune the workload, not tune the query. So this is going to help us tune that workload. Okay. So these are the things that we got with the memory grant feedback kind of capabilities. We got the improvements with the percentage approximation. So basically, stats, we can kind of probably use some additional information as well and get approximate number of rows from the kind of information we have inside of the metadata stores to say what's the percentile counts and distribution of that. We can also look at the optimized plan forcing as well and get better persisted plan steps for that. So kind of using that, and again, that's coming from that query store, the optimized plan forcing. When we got the memory grant feedback percentiles, we also got that persistence feedback, and then we stored that information now in that query store. So query store now gets that additional new information about the memory grant feedback. Really cool. Now, I'm not going to kind of go into the parameter system plan optimization day, but kind of just to kind of give you the heads up on that. Basically, we want to have a plan sufficient for the parameter that we're putting in there. So if we need a seek, we get a seek. If we need a scan, we're going to get a scan. What we end up with is essentially separate kind of plans based on what is called a variant inside of the engine for that. Okay. So I'm not going to go into the details. You'll have access to these slides and details here. So this is essentially figuring out where we're going to get that query variance, and then what kind of plan we're going to use, and what kind of memory grant is it, a small, a medium, or a large memory grant that's going to be assigned based on the variant values. Okay. Okay, so I'm going to go kind of skip past that a little bit more, and we're going to go into this cardinality estimation. Just want to do a time check. Okay, cool. So we're going to go through this very, very quickly, and then we're going to jump into a couple of demos, and then I'll kind of, because I think we're going to about 1:45. So we've got about 35 minutes left in the clock kind of thing. Then let me know if I got that wrong math-wise. Okay, so essentially, we're going to look at the new compact. We're basically looking at anything above the 120. So the new cardinality estimation model, not the old one, the new one. Well, basically, you want to be on the latest, greatest version of compact, unless there's a reason not to be there. So if you haven't upgraded and you've got no valid reason not to upgrade, do the upgrade to the latest 160 for 2020, 150 for 2019. Walk down the stack, the numbers. That okay. So what have we done here? Well, basically, we've set a scoped configuration for what the values will be. And we're basically kind of internally now working out this information about the cardinality. We've got better numbers, better metadata, better kind of query engine fixes that are going to do a more kind of updatable on your stats based on percentage changes to the rows that are kind of more variable. It's not like waiting for a huge number of rows to change before we do those stats updates. Okay, so we improve the engine features on that. And this is going to give you an example of there between this example where we're doing a parameterization on a specific state province ID and also the value of the city being a specific one here. So is there a correlation between Redmond and the state province ID? Do we understand this? So what we have is we have these correlations that are going to kind of be helping to understand if the correlation exists. So for full independence, we would be using a trace flag or the legacy model. For partial correlation, we were looking at the new CE model, the 120 and above version. Again, we might be using a query hint or a trace flag for that. For full correlation, we're kind of looking and basing it on just the hint on the trace flag. Now, that is kind of what we were doing with kind of understanding if it's partial or full correlation between these two kind of columns and stats and the rows of data there. Okay. So this is how the engine figures out this stuff. Okay, so this is quite a kind of bit of a flow there. We look at the execution plan and we look at repetitive kind of plans that have the optimized query parameters. We're going to see, do we have any query store hints? Anyone hints? No, okay. Hopefully not, because you probably don't want those, really. If you start using them, they could be good for a while, but then you could get into scenarios where your hints are now out of date. Okay. We're going to check that the performance now has been improved or degraded. So we kind of make a change and we validate against the baseline of data we have. Did we make an improvement? If it is, we're going to persist that new query hint in the query store for that improved value. Otherwise, we're just going to discard it and move on. Okay. We're going to basically look at those query hints that we have stored over time, and we're going to apply that to subsequent and kind of executions that come along. And over time, that helps us kind of look at, are we using the best plan, the best cardinality investment values, and the hints that we have are going to be useful. So that's kind of what we're trying to do with the CE. Okay. You don't really have to do too much. It's kind of built into the engine. It's going to do a better job. There's not really too much control you have over this, to be honest. But what it's doing is it's storing that data in those internal structures, tables inside the query store, inside your user database for any kind of improvements it's tried out, and it's kind of capturing whether that was a good or bad improvement there. So the thing we're going to be focusing on today for demonstration purposes is the degree of parallelism, the dot feedback. So what do we have here? Well, the problem, or the age-old problem of match dot, maximum degree of parallelism, has been what's the optimum value I need to have? Now, remember, you do this on a per database instance level, but really the queries can be very varied on that. And also, if you're talking about transactions versus kind of queries where you're doing lots of data processing, your degree of parallelism really should be quite different for those type of workloads. So you might be offloading your readable replicas for your availability groups and having a completely different, really good value for your degree of parallelism for those than you do for your transactional queries. So we look at each query or workload separately and go, what's the maximum value? What's the kind of value should I have? And really what we're trying to do is to figure out what's the kind of the limit, the high limit. And if I've got 8 cores, is it going to be a max DOP of 8? Is a max DOP of say 6 or 4 or 2? Generally, you kind of jump in increments of 2 for kind of allocations here. How many threads do I need? How many parallel IO operations am I trying to run? What's the kind of optimum number here? That may be slightly high or slightly low, depends on kind of what your configuration might be. And that could change over time as well. You could be auto scaling in terms of resources, your service to a higher number of virtual cores, and then later on coming back down again. So we kind of might have a variable number of essentially virtual cores that we're using that we then have to kind of be allocating maybe a different DOP for that. So generally maybe something like you kind of start with say like a 4 degree of parallelism, and then sometimes you might find for one specific query an 8 would be better. But I don't want to set it 8 for everything, because that's going to kind of then allocate 8 threads for every query where I need parallelism in my query plan. So I want to kind of have this adaptive query, number of threads, number of DOP for that query that I'm running. I'm going to show you how we can figure that one out. Okay. So basically finding the lowest DOP to get me the same execution query time, and that's the duration. We're talking about milliseconds here. What's the execution time? And also probably looking at the amount of CPU kind of that's being utilized. Okay, so here's an example of the architecture, and I say there's another kind of video that goes into more detail about this. But basically, we do a number of stages here, and I'm going to demonstrate this. Actually, what I need to do, let me just kick off my query, because I want to kind of, my workload, I want to start it to generate some data while I'm going through this. So give me a second. It's going to jump into our, if I can find the example where it is. There we go. Okay. All right. So what I'm going to do is I've already prepped up some of my segments. I've set up the database. I've restored it. I've upgraded it and kind of made it slightly larger in size in some of the data. I've also rebuilt one of the indexes. Now what I'm going to do is I'm going to set up my query store. Okay, so let me kind of, and I don't have Zoom running for some reason in my Bastion, which is like my web interface into my RDP session. For some reason it doesn't want to work. I tried it earlier, it's kind of blacked out screen. So here you might not be able to see it very well. I've made it a little bit bigger just for visibility. Maybe that will make it a bit easier to read. Okay, so I'm going to turn my query store on. This is my restored database. Actually, if I go and just refresh this one here, you'll see that I have that database there. We go to properties on that and go into kind of the query store. You'll notice that this is what we have currently set up. Here's the query store. Basically, it's 500 meg in size. It has some parameter values, and I can see kind of what it's done. Yeah, this is kind of ready to go. And we should be good to go. So I'm just going to kind of reset that just to make sure everything's good. And I'm resetting the compat level, and I'm clearing my query store of all my previous runs, just so kind of I can make sure that this example has just my new query stuff. And let's kind of run that. Okay, and then I'm just going to kick off this next couple of things just to get this running. So what I'll do is I'm going to create my store procedure. So that's going to be my parameterized store procedure. Oops, I need to run the whole thing. There we go. And then I'm also going to run, by the way, all these steps that I'm showing you are in that that exercise, and I'll show you where you can actually see those. So I'm going to create my new degree of parallelism feedback extended event session, okay, and I'm going to then start it up. And I'm capturing some key information here. So let's see what we have kind of installed there. So basically, we're capturing basically query degree of parallelism feedback provided, eligible, stabilized, validation. So an extended event session for this. Let's just start that off. Okay, and I'm then going to, that was number 6, I think that's number 7. I think we need to just run our query now. So this at the moment, notice if I run this, I have nothing in there whatsoever, okay, because I haven't run it. I've just set things up. So let me go and run my query. I'm going to use the IO stress tool, OS stress tool, I should say. Going to run it and just basically going to create a workload recess there. Okay, so let me kind of run that. Okay, so that should, let me kind of just make sure that this is off and running. Looks like it might be. Okay, cool. So I'm just going to go and see if I can get my extended event session visible. And I'm just going to turn on my live data feed, because what we'll do is let this run for a bit, and then we'll come back and we'll look at some data that's going to be spat out of this live session, and hopefully that gives us the information. So you can see I've got my first eligible query that's kind of been figured out and queried. We'll come back and look at some stuff here. I do want to actually just do a couple of things here. I want to look at my speed, my CPU time, and my degree of parallelism. So I want to look at what those numbers are over time and work out when they're improving. Okay, so actually let's kind of just put our query at the end there, just so we can kind of see that the query is the same query every time. But what we should find is that the degree of parallelism and the CPU time should be reducing down from the 8 CPU. This is an 8 CPU core virtual core machine at the moment. Let me just make sure I've got that right. Let me go to Task Manager and go to Details, and we're going to go to Performance. And if at the moment, if I'm right, we do have 8 virtual cores and I think 64 gig of RAM at the moment. Okay, cool. All right. So we'll come back and look at this a little bit. This is just kind of kicked off to get some workload. It takes about 10, 15 minutes so to complete its cycle. Okay. All right. So where were we? So we're doing that eligible query right now. We're finding, is the query suitable to be reviewed for degree of parallelism feedback, i.e. the query plan has a parameter, an operator that has been parallelized. In this case, it's got 8, a DOP of 8 at the moment. Well, we're going to look at the query store later on as well and see where we can see the plan changes that have happened as well. Okay. So we provide the feedback. We are doing some validation where maybe adjusting the number, and then we're kind of to look at whether that's a stable, revert, or kind of minimum kind of level for that, and it's happening in the background. We're constantly reviewing these query stats and the executions from the data that we received and figuring out, can we do things quicker and better with less DOP, i.e., 8 down to 6 down to 4 kind of thing, for that same query, but without sacrificing any performance characteristics there. All right. So each eligible query needs to have a longer duration and be penetrable. So kind of we want to kind of say, hey, this query needs to be kind of looked at to see if we can improve it. So not every query can be improved, of course, and we might not need to do that. And also, how often do we run the query? Needs to be repetitive enough to be there. We're trying to figure out that lower CPU usage case. What's the kind of sweet spot, essentially? What's the minimum DOP there? So less CPU for that specific query means that we're making that CPU that we kind of, if we've gone for 8 to 4, for example, then we could run 2 of those queries at the same time. with the same amount of resources we have. A good note, CPU licensing is really expensive, especially for enterprise, okay? So if you can go and look, you know what, if I can get better CPU kind of DOP for my queries, essentially I could actually make that, 16 core down to maybe a 12 or 8 core implementation on my server. I could reduce my amount of money considerably because I've gone with DO2P kind of feedback to improve the resource utilization levels. Okay, so we want less CPU. We want to start from the current level, and we want to kind of essentially go a little bit lower. Try the next step down. Does it still go well? Okay, good. Okay, we're at the next level down there, and we want to try that again. At some point, we'll get to the point where we can't go any lower because essentially we're not getting any performance improvements. It's either taking longer or kind of that we've hit the sweet spot now. Okay, for that specific query. I'm going to factor out some of those common. So we're looking at CPU weights essentially. We're looking at CPU's execution time. We're kind of taking those kind of those common weights about kind of IO completion and kind of waiting for locks and stuff out of the equation. That doesn't matter when we're talking about duration. We're talking about just the CPU time. So we're kind of looking at the CPU durations essentially. And if we recompile, do this all again. So over time, you might have recompiles, stats update, data changes, things get recompiled. You turn the engine off, you turn the engine back on again. Would you have some kind of persistence on the plans themselves a little bit? But remember, when you first start the engine, it's cold. It's been restored. There's no plans. I've done a plan cache clearance. I'm starting from scratch there. Okay, so that's when you start building up your plan cache, your procedure cache, and starting kind of with the numbers. You may find you have to go through that cycle a few times again to get back to the optimum. Okay. So we're going to jump into those exercises, demos essentially in this case. And the ones that we're going to look at are the memory grant feedback and the DOP feedback. So we're not going to do the first one, 3.1. We're not going to do that today, but you will be able to do that from the exercise materials. We're going to look at memory grant feedback. We were doing the DOP feedback first though, and then with what time we have, we'll look at maybe the persistent memory grant feedback as well. Okay, so we're going to see how much time we have get through. Okay. Let's see if you're paying attention, actually. I'm just going to give you a couple of knowledge checks as part of the deck and see if you can figure this one out. So here's the question. See if you can figure out which of these is the correct answer. All right. A few more seconds and then, okay, let's do a drum roll. All right, ready? The answer is new databases, version 18 and 19 of SSMS, or you want to kind of do some of the other kind of Azure Data Studio and stuff like that. Basically, a new database that's in SQL Server 2022 edition engine that will have the query store on by default. And also, if you use the use create database syntax as well, inside of a query then also. So anything where we kind of create new databases. Okay, cool. If you restore a database from an earlier backup, like I did in my demo, I have to go and turn the query store on for that database because it's from an earlier compat level version of that, which is SQL 2019 or before. Okay. And when you're talking about managed instance, things get complicated, so we're not going to go down that road at the moment. Okay. We're not going to parameter sensitive plans. Basically, the answer, I'm not going to, I'll show you this for a second. Let's see if you want to figure out the answer yourself. So yeah, another drum roll, please. Let's see if we can get this one right. Ready? So basically, the answer is where we have a plan that is optimized for the parameter value. So where we have, say, a skew of data, and parameter 4 has 5 records. Parameter 8 has 500,000 records. Clearly, one will probably be an index seek, one's going to be more of a scan. We have 2 different values. That variant I mentioned earlier is going to come to the world of having more than one plan inside of the engine. I do remember I was at SQL Pass back in the end of last year, and there was a little quiz that was being done, and they said how many plans do exist for a query, and of course up to then it was one plan for one query. I went, well, what version of SQL are you talking about? And they went, what do you mean? I went, well, 2022 has more than one plan for a query now, based on the variant. And they went, that doesn't, well, it does, but you have to have Compact 160 and turn it on and stuff. As I and turn around, and it was my friend Kevin. It was like, oh, it's Neil, yeah, whatever he says. Because this is kind of the stuff that I read up about, and when things come out, I'm checking on this stuff. Okay. CE feedback. How does this work? So here's the options, and which of these will be the correct answer? So if you were paying attention when I did that explanation, which was quite a rapid fire one, so you may have skipped, missed it. Here's the answer. It is, when we find an improvement, we're going to store that specific hint and persist that in the query store for that specific kind of thing. So basically, yeah, we tested it. It did actually improve it. Let's record that value. We're good to go. Okay. And essentially what we're trying to do for parallelism, degree of parallelism, which is what we're going to look at next, is one of these. Which one of these is it? Is it A, B, C, or D? And if I explained it well, who knows if I did that or not, during my explanation, you should have picked A. Answer B, everyone. Yeah, cool. All right, so we're trying to get the minimum DOP for a specific query where the duration of the execution is kind of the norm or even lower, but we have the lowest CPU allocation of values DOP at the same time. Okay, so that's what we're trying to do there. Okay. All right, so let's go and see how that that query has been progressing. Is it ready to give us some insights here? Okay, let me do a time check. 1 sec. Okay, so we're about 10 minutes left. I think kind of in there. We're gonna have a few minutes for questions as well. So let's look at what we have. Right, so this is the summarizing what we have. By the way, again, everything you'll see in the slides here are part of that workshop that you can kind of sign up for, and I'll give you the links in the chat segment shortly. Okay, so upgrade to 2022. If somebody says, oh, there's a reason why they don't want to upgrade, just send them over in my direction, and I'll explain the benefits of going to 2022. So yeah, it's definitely well worth the move up and the workload to do that as well. Okay. So there's a whole bunch of links here as well, and resources and books and stuff, and blog series and videos. So kind of if you kind of ever seen some of the kind of data exposed series with Anna Hoffman and Bob Ward's on there frequently talking about SQL Server 2022 and that kind of stuff. Loads of great stuff, and all the demos, by the way, are in the SQL Server, SQL Server 2022 demos link now. Okay, so let's look at our query. Wow, it's looking healthier for sure. Okay, so let's look at what we have here. And it's a little bit hard to kind of see. So I'm actually going to stop that query a little bit. Let me kind of just, go and stop that feed. Okay, now what we do is also at the same time, I've stopped that feed. I've got my results now of my live extended event session. I want to go and open up my worldwide importers database, and I'm coming down to my query store. Okay. Now, here's where I can look at some of the results. So I'm actually going to look at the top resource consuming queries right now. Go to the reports for that. Okay. And I'm going to see what we have here, because essentially we have a whole bunch of variances here. And I'm going to show a few of those in a moment. Let me just prep up a couple of these 1 second. Oh, okay, also I need to click that area. And also notice we see that things like the leading, missing index notifications there. Okay, all right, so let me find the CPU time. Okay, so you see the CPU time has been kind of a little bit different over the time. And we kind of actually go into this version here. So I actually want to pick a couple of plans. So for some reason, I've only got plan 1 there. So I may actually rerun that query again 1 sec. So if I have it there, we kill that one and run it again. So I should get another query plan, maybe a different plan ID there as well. But we'll see in a moment. Okay. But let me go and also get a couple of those queries, additional queries I want to run. So I want number 7, I think. So I actually want to look at that result here. Let me just see what we get. Okay, so this is going to give me the results of essentially, where was that live data feed there? Okay, so you see here, we started off with an eligible query, and we had the CPU time for that eligible query for this store procedure with the parameter number 4. Okay, and we can also see the text, we can see the query hash, we can see the plan hash, all the great details there. Okay. At some point though, it's figured out that we could basically move that down to a improved number from 8 DOP down to 6. Now it's going to provide another series of validations on this here. Okay. And here you can see that we kind of go through the validation process. And again, at some point we've said, you know what, actually, let's try 4 now. Let's try it with 4. And let's look at the execution time and see where that comes from. Now we can see that we do have a stabilized version that's using 4 grid powers. And in fact, actually, we look at the average CPU value and the adjusted values. So let me kind of put these numbers in. So this is what I'm looking at. So 35 seconds. 35,000 is basically 35,000 milliseconds. That's 35 seconds. We went down to 30. We had a slight adjustment there, 30, 31, 32. But we're now at 31. So basically, the 6 has actually improved from the 8. We've gone from 35 seconds. Average CPU time millisecond down to 31. Cool. Now, in fact, actually, we look at the number 4 as well. We're actually at 27. So we've been improving our average CPU time by even lowering the actual value. So we're actually going faster as well here. Okay. So that's going to give you some examples of those. Let's go look at the top resources there. Okay. And let's kind of refresh the screen. So 1 sec. Where's that refresh on there? Okay, let me close it out for a second, because it should have been a slightly different query. Anyway, there we go. So here is I've got my query plans. So it looks like I've only got plan 3, and for some reason that's not giving me the details. So I'm actually looking to see where the speed was on this. So we did 1,600 executions. We've got 30. I want to see the average duration, min duration. So it looks like we only got 1 plan. I should be seeing 2 plans here. Looks like this query hasn't quite played out as I expected. Because I'm only seeing the index scan here. What I should do is also see the index seek as well as a different plan. So for some reason, this one hasn't given me that other plan. So what I can do is just go and run a different query here a second. We go back here. And let me go run the query where I want to run that execution with a value of 8. So I'm going to try and paste it as. Okay, that didn't work. Try again now. So you can find the right query. So that's the one I want. Okay, there we go. Let's copy that. Go to number 9. So here's the execution of the query. So let me run that one, and basically we get that query plan for that parameter, and that's going to be about 30 seconds or so. So what I'm going to do is I'm going to also run this now with a value of 8. The first one ran, and we'll wait for it to finish. So it's ran about 27 seconds, I think it's going to be, and you'll see how many rows come back from that. So give it a couple more seconds, it should be done. We are nearly out of time, everyone. So there's kind of, if you have any questions, get those in. And we've got about, I think, 2 or 3 minutes left in our schedule here. So let me just wait for this query to finish running. And this will be wrapping up then the session. Okay, so 42 seconds. It's taking a bit longer. Why? Because I'm actually getting the data. Whereas when I ran it as some code, I actually wasn't receiving the rows. Okay, so I'm going to just put that in a different window because I know it's going to take a while. I'm going to run it with number 8 this time. Okay, so what we have, we want to do the query plan on that. So let's go grab that. One sec. So this is the one with the index seek. Okay, so basically it's the same store procedure, but with a different parameter. So if I now go and look at my top presumed queries, and it's probably not thrown out the data into the plan yet. So do I have enough plan? No. So for some reason I don't have the plan ID yet come through into the plan cache. It will async send the data every so often from the in-memory objects, which are kind of the DMVs essentially, and the buffers that we have. So hopefully that was going to come through, but I'm not seeing that other plan hit yet. Okay, I think we're out of time for that. You can run the demos yourselves. You can see the results of those. But essentially, I was going to show you an example of it basically improved the CPU, as we saw from that earlier example there, which is annoying. Oh, there it is. Okay, so you see now we've got 2 different plans. There's our clustered index SAN. And we should have plan ID 25 now. And yeah, so we're kind of seeing that we do have 2 different plans, plan 25 and plan 13. For some reason we're not showing them both together on the same screen. Anyway, I'll kind of hold it at that point.